All right, first things first, let's take a look at what a browser is. So what is a browser? A browser is a program that asks a website for information. This ask is called a request. And when the request is completed, the website returns an answer called a response. It's a lot like when you pick up the phone and you call your mom or your dad or your best friend. They pick up their end of the phone, they say, hello, that's the response. Now the response has data in the form of HTML, CSS, and JavaScript. It can also include things like images and other forms of data, but we're not really going to touch too much into what that is. But really you just need to know that the response has this thing called a payload and it sends back files. And then your computer downloads all of these little tiny files and your browser is the program that reads them, pieces them all together, and makes your beautiful website. Now when it pieces things together, that's called rendering. So it's going to try to render the final output. Now there are 4 major browsers. There's actually thousands and thousands of browsers out there, but there's 4 major ones. Google Chrome, Mozilla Firefox, Apple Safari, and Microsoft Edge. But again, there's hundreds, if not thousands, of smaller, lesser known web browsers available. Your phone might even come with a different one that's not one of these 4. What does your browser do? So your browser collects information and its job is to display it. Now when it collects information, it's actually just asking a server, hey, can I have some information? The server says, yep, you can have this information, sends the files. Your computer then downloads them, or your browser will download them, piece them all together in a nice way, and kickstart all the code. And that sort of creates your nice interactive website. Not all browsers are the same. That should actually say not now. Not all browsers are the same. So what works on one browser may not necessarily work on another browser. So if you ever stumble on a website that seems broken in, let's say, Google Chrome, try opening it in Firefox, or vice versa, or Apple Safari, or Microsoft Edge. Just try it in another browser, because sometimes the rendering engines behind the scenes don't work the exact same. They're supposed to, but they don't always. Your browser's job is also to communicate. It's responsible for the communication/transactions between your computer and the website. And again, it's like picking up the phone and dialing your best friend. You need to wait for them to actually answer the phone, say hello, and then you can start a conversation. What are web requests? A request is simply asking for information. So web requests are when you ask for information from a website. You're simply asking for the files that you need to display the website. And often this is called a handshake. So let's take a look at how this works. It starts off by going to a website like google.com. Your browser then asks google.com for the data it needs to display the page nicely. Now this whole process is called a request, and actually when it sends you the information back, it's called a response, but we'll touch on that in just a little bit. Requests can have sizes as well. So a request can be literally any size. Google.com is a small request, or really any website. We're just going to the website and saying, hey, can we have the files? And then the website determines what it should send back. But that first request, that first handshake is usually pretty small. Now, if you load up something like Instagram.com, every image will be a new request. So as you scroll through your Insta feed, it's going to load more and more images, and that's going to be a new request every single time. Or if you go on Facebook.com, every comment you make, every like that you click, those are all requests. It's a different type of request, and again, we'll get into that in just a little bit, but all of those are called requests. Anytime you send a little piece of data to a website to either ask for information, or even to ask to delete information, or update information, or to save information, those are all requests. And these are called request types. So sometimes a request comes in the form of asking for information. And this is called a GET request. But it can also be in the form of asking to save information. Now technically, those are called POST requests. There's also a delete request to delete information, and a put or patch request to update information. And once again, a normal handshake is just a GET request. That's the most common one. And this is actually getting into RESTful APIs. Now, if you're interested in APIs, I have a course on RESTful APIs. Feel free to go and take a look at that after this course. Now, one thing to note is that everything has to travel through the internet. Smaller requests and responses means less bandwidth. It means it can travel through the internet, through the wires that are sent all across the globe, through your Wi-Fi. It can serve that a lot faster because it's a lot smaller. It's a lot like this. Think about the last time you had to download a 1 gigabyte file versus downloading a 1 kilobyte file, right? The 1 gigabyte file takes a little while. It could take several hours depending on your internet speed, but a 1 kilobyte file, even if you have fairly slow internet, is still a very, very fast download. Requests are the exact same thing. The request lifecycle. So let's take a look at how this begins. When you ask for information from a website, you're actually doing a lot more than that. When you ask, let's say my website, caleb.io, for information, there's a domain mapping behind it. So caleb.io actually points to an IP address, and that IP address connects to my server. So you're not actually requesting information directly from caleb.io, it's just sort of masking it so that you don't have to remember IP addresses. And then how it ends. The server is going to accept my request or your request. It's going to understand what it's supposed to output and sends files like HTML, CSS, JavaScript, images, all that other stuff that makes your website look good in this thing called a response. Lastly, the browser downloads these files and saves them onto your computer. And if it has to download it more than once, sometimes it'll just use the old files, and that's called a cache. It's going to then piece all these files together and render your content. What are server responses anyway? So a response happens when a server responds to your web request. A response happens after the request is made, so it always goes request and then response. And responses can be pretty much any format, but typically it's HTML, CSS, JavaScript, or plain text or JSON for like an API. If you don't know what an API is, honestly, that's okay. You can just ignore that bit. But if you're interested in learning a little bit more about APIs, there are some cases where an API, also known as an application programming interface, will send XML or JSON formatted data. Now, typically it's kind of like plain text. It's not really specialized markdown too much. It has some rules, but not too many rules. But the nice thing about that is because it's sort of plain texty, that means there's not much to interpret, and your browser can deal with this a lot faster. Or your server even could deal with this a lot faster and then render HTML, CSS, JavaScript, whatever it needs to do. Now, often, JavaScript or a server programming language like Python is going to handle these API responses. Again, if you don't know too much about APIs, if you're brand new to web development, don't worry about this part right now. So as an example, when you load up Instagram.com, you're making a request to the website to load the initial data. As you scroll down, it loads more and more images dynamically, so that the first request can always be small and fast. It really only shows you, or tries to get like 2 or 3 images, but it's not going to save 1,000 images, or it's not going to ask for 1,000 images, because that's going to be really slow to load. Your request is going to be a pretty small request payload, and that response is also going to be a fairly small response payload. And that just means that, for example, Instagram.com can load really, really fast. Now, as you scroll down the page, you're going to see that more images show up, and sometimes it's so fast you don't even notice. That second request, third request, fourth request, when you click load more on any website or you scroll down on Instagram, is usually an API endpoint that returns JSON or XML, and the reason is because both of them are a lot more lightweight than HTML. Then your browser reads the JSON response, for example. JavaScript takes over, and it says, oh, I need to display more photos, and it dynamically creates your HTML structure for you and adds it to the page. And as soon as it's added to the page, your browser then takes over for JavaScript and says, oh, I need to make another request. And then the cycle repeats. The server says, oh, there's a request coming in for this particular image, serve that image. Now, on the topic of images and other assets like images, each one is likely to be its own request. So the browser creates a new request for each image file to download. The server sends a request with the image data, and again, your browser then displays that image. Though technically there are ways to bundle responses together for a faster one-time payload response. This way you can just ask the server once, and it will send all the images all at the same time, so it doesn't have to go one by one. And again, that just makes that response payload faster. And the reason for that is because if you think about driving to and from work, or to and from the hospital, or to and from your house, there's a lot of travel time in the internet. And so if you can reduce the travel time and just carry all the images in one load, then it's going to be a lot faster. Interpreting HTML, CSS, and JavaScript. So these are the most common response data types. So when you make a request and you get a response from a server, you're likely going to be getting HTML, CSS, and JavaScript. Your browser's job is to download each one of those files. But the browser also has these things called engines. And so these engines have certain rules for HTML. They have different rules for CSS, and they have different rules for JavaScript. If your browser thinks it's opening a JavaScript file, it'll use the JavaScript engine to read and interpret and make your website interactive. Likewise with CSS and HTML. So if it realizes that there's a CSS file, a cascading style sheet file that is, it's going to try to interpret that and make your website look good. And so they have different purposes. Once all the files are downloaded, as best as they possibly can, it's going to piece them all together, and again, it's going to try to display your website, or it's going to perform a render. But at some point, JavaScript is going to take over the browser, just because the browser has a particular purpose, but JavaScript also has its own purpose. So after the initial response is rendered or displayed in your browser, most of the time, JavaScript is going to take over. Not all the time, and sometimes there's some cooperation between JavaScript and your browser. JavaScript can tell the browser to make more requests on the fly by dynamically adding links, images, and other assets to your page, or by directly communicating with the browser and creating a new request. So JavaScript can make its own requests, but your browser can also make requests too. Viewing your requests and responses. So to view any sort of request and response, you're going to need a modern browser. I recommend Chrome or Firefox for this. And then I'm going to demonstrate in just a second how I can see all the responses from a website like google.com. So you're going to want to pay close attention because you'll be trying this in the next video. So I'm just going to get out of this and go over to google.com. And so this is just the regular Google website. And what I can do is right click, go to inspect. And you're going to see these options in here. Now yours might be a light color mode, so I've got dark mode on, and this might actually show up on the right side or the left side, but either way you're going to see sort of these options here. For us, we're going to want to go over to the network tab, and we're not going to see anything in here, and I have mine filtered by CSS already. Let's go ahead and filter that by all, and if you don't see anything, that's totally fine. This is going to process all the requests that are coming in right now from the time you open this to any time you close it. So let's go ahead and just click refresh, and we can see all these requests were coming in. And so there's a lot of different things in here. We have a document, which is HTML. We've got a PNG, that's an image. WebP, that's also an image. We have a plain text one in here. We've got a text HTML. We've got a script in here as well. We've got all sorts of stuff that we can see. And maybe what I'll do is I'll just make this a touch bigger. So if we wanted to see an image, we could right click and then go to Open in New Tab. And that's the image that it loaded. So we now know that Google made a request for its own logo. Let's take a look at another one here. Right click, open in a new tab, and this is what's called a sprite. So it's one big image with all these little symbols in it, and then it uses CSS to sort of display the images, like just a particular part of it, so like just the notification sign. Now the benefit to doing this is it's making one request for the image instead of making 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I don't know, 20, 25 requests for all these different images. It just has to do the one. And so that's significantly faster. And that's how Google loads so fast, is it really optimizes these request response life cycles. Now you can also filter by JavaScript. So let's see what happens when I type in here, KALOB. And you can see in here that it's doing a search for Q is equal to K, Q is equal to KA, Q is equal to KAL, and as it types, it makes a new request every single time. Now this is all JavaScript. This is not your browser, this is JavaScript doing this. And this is using a thing called AJAX, or the Fetch JavaScript API. If you don't know what those are, that's honestly okay. We can look at just JavaScript requests. So these are the files that we requested from JavaScript. We didn't request any CSS at the moment. I don't know why that doesn't seem right. I guess there's no CSS in there. That probably means if we go into here, right click and view page source, we're going to see all the CSS in here. And there it is. All the CSS is in the page. So it wasn't loading any CSS files. It came with the HTML document. Interesting. We can also see all the different images, medias, fonts, documents, WebSockets, manifests, all these other things. Now we can also see, if I just go back to all, how long it took to get, what the file size is. We can filter by the file size here. We can see the biggest file here was the document itself. That's the entire page. It was about 61 kilobytes and it took 140 milliseconds to get. And again, the idea here is that I went to google.com. Google.com is going to point to some form of IP address that's going to connect to some server that they have. That server is then going to say, oh, okay, well, serve this HTML document and serve all these other assets with it as well. And so essentially, I asked for a bunch of information. I didn't even know I was going to be asking for all of this, but I asked for a bunch of information from Google. Google determined what information it needed to give me, and then as a response said, here, have all of these files in here. And that effectively is how you view your requests and your responses. Again, you don't need to use Google Chrome. I was just using Chrome because that's the tool that I like to use when I'm doing things like this. But you can also use Firefox, Safari, Edge. Really, any browser will be able to do this. Your project. So here's what I would like you to do. I want you to open your favorite browser. Could be Chrome, Firefox, Safari, Edge. Load up my website, just as an example. Go to caleb.io. Right-click on the page and then inspect, and then click the network tab, and then refresh your page if you don't see anything like we did in the last video. And then I want you to be able to filter your responses by documents, so like HTML, CSS, images, or JavaScript, and just kind of see what kind of things my website's going to try to serve you. Find an image and then open that image in a new tab, and then take a screenshot of your network panel. Just the entire panel, not the image itself, but take a screenshot of your network panel while it's open with all the different requests and responses in there, and share it in your project section. Now don't worry, anything you're doing here, it's not going to break your browser, it's not going to hurt your computer, it's not going to do anything that you can't undo by simply clicking the refresh button on your browser. So feel free to experiment, it's completely safe to do this. Go ahead, give this a shot, take a screenshot of your network panel while it's open, share it in your project section, and once you're done that, you have completed this course. Thank you for taking the time to watch this course. I hope you learned something new and exciting. Again, this is really important when it comes to web development. And if you wanted to learn more about HTML, CSS, JavaScript, APIs, anything like that, always feel free to view my profile. I have courses on all of these subjects already. Thanks again, and I hope to see you in another course.